Okay, so the way you go about doing something like this is you draw each piece of information one at a time. One at a time. So first of all, let's draw a set of axes and go from there. Kids, hi. So what's the first thing it says? It says f of 0 is 0. The next thing it says is f prime of negative 2 is equal to f prime of 1 is equal to f prime of 9, which is equal to 0. So what happens at each of those x values? So here is negative 2, here's 1, and here's 9. What happens at each of those x values?
0.
The derivative is what? The derivative is what? 0. It tells us that the derivative is 0 in each of those cases right there. It tells us. Does it tell us anything about where the point is at those x values? No, it doesn't tell you about anything where the point is, but it tells you that the derivative is 0. So what you could do is literally you could just say, you know that the tangent line is going to be horizontal. So this right here is going to represent the tangent line. Whenever the graph crosses these dotted lines, the tangent line is horizontal. That's what you know. The limit as x goes to infinity of f of x is 0. So as it goes to infinity, which is infinitely to the left or to the right? To the right. So you know as it goes, it's going to go to 0. It's going to get closer and closer to the axis. It could be either from above or from what? Below. So it could either do this or this. I'm just putting in all the choices. And we know that as it goes to 6, it goes to what? Negative infinity. So what does that tell you happens at x equals 6? A what? What type of asymptote? We know here what's going to happen. It's going to, as x goes to 6 from both sides, it's going to negative infinity. So we know that this graph has to go down, right? Like this. As x goes to 6. So when it goes to 6, is that a sided limit? Is it saying left or right there?
No.
It's saying both of them. It's saying both of them. So it's going infinitely down. So we've done this one now. Great. What does this mean? The derivative is negative when x is less than 0? Oh, sorry. The derivative is negative from negative infinity to 2, to negative 2. So what's going on? What does a negative derivative mean? It's decreasing. So it's decreasing all the way to what?
Negative 2.
It's decreasing all the way to negative 2. So let's decrease this thing all the way to negative 2. But what happens at negative 2? What do we know happens at negative 2? It levels off. And where is it decreasing? From what to what?
1 to 6.
1 to 6. So let's say there it is right there. So we did this one and we did this one. And from what? 9 to infinity. So does that mean from 9 to infinity it's falling? So which one is it going to be? The upper one or the lower one? If it's decreasing from 9 to infinity. Which one of those curves? The upper one. So we know it's the upper one has to be this. So we know it's going to go something like this. Like that. We know the derivative is 0 at 9, right? We know it's positive between negative 2 and 1. So what's happening from negative 2 to 1?
It's increasing.
It's increasing. So we know it's increasing. And then it's 0, correct? Is there a little... What's the problem right here, do you notice? They should be connected, right?
Yeah, so we have
So what should I do? I should just bring it all the way down, like that. Exactly. There it is. So that takes care of this part. And we know it's increasing from 6 to 9. Oh, look. So it's going to go like this. 6 to 9. Now, what do the last two lines talk about? The second derivative tells you about what? Concavity. So it's concave up from negative infinity to 0. So does it already look like it's concave up there? I think I already made it kind of concave up there. That's good. So we took care of that. And from 12 to infinity. So we're saying right here. So what would we have to call this value right here? 12. Changes concavity. Yay. And then it's concave down from 0 to 6. Does that look like it's true?
Yeah.
Yes, it does. And from 6 to 12. So how's that look? Inflection does it have? 2. Changes points of inflection has to be a point. So there and so there's an Oh, it does?
Yeah.
Ah. So what would we need to do? We'd need to, I don't want to redraw this. We'd have to bring this point just down there. Do you understand what I mean? So you're absolutely right. We have to make sure it intersects right there. So all we do is we pull this down. Does this thing tell us anything in here? Do these qualifications tell us anything about the x-intercepts?
No.
It doesn't say anything. So can we easily just take this and stretch it down?
Yeah.
So what is it? What should it really look like? Well, we can delete it. Let's fix it. Why not? So what's it really going to look like? Sure, like that. So from here to here, it's concave up from all the way to 0, right? And then what does it change to?
Okay. Down.
Oh, you know what? It doesn't have to be. Sorry, it has to touch at 2, right? Like this. Because it's concave up and from 0 to negative infinity to what? From negative infinity to negative 2, right? It's concave. And then what does it change to?
Concave down.
Oh, sorry. Right here is concavity, right?
The value
So-
x equals
so it's-
2 is like below 0.
Yeah, that's what I'm saying. So you know it's going to have to go down like this. And then what is it going to do? It's going to go up. And then at 0, it could change, right? Like this is what I'm saying. There you go. So that's a little better. So it's concave up. And then what does it change to? Concave down. There it is. That's a little better. So that fits all of those right there. So f of 0 is 0. Is this correct?
Yeah.
Looks like it. Yep. Good. It's continuous and even. Is that continuous? Yeah. Can you draw it without picking up your pencil? Mm-hmm. Is it even? Meaning is it symmetric over the... Is it? Yeah. Okay. 3. Good. F prime of x is equal to 2x between 0 and 1. That's this part. This is a little tricky right here. So from here to here, is the derivative of that 2x? It is, actually. It's good. F prime of x equals negative 1 from 1 to 3. So it's got a slope right there of... So is the slope from 1 to 3 equal to negative 1? What does it look like? Yeah. Good job. And f prime of x is equal to 1 for x greater than 3. F prime of x is equal to 1, so that means the slope has to be 1 for x greater than 3. That's really good. And then you did it on the right side, so it has to reflect over the y-axis and do the same exact thing. This is really good. Good job. Yay. I like that a lot. Here. What's the first thing you figure out? The domain. You always find the domain first. Always, always, always think about the domain first. Can you tell me what the domain is? It's x such that x doesn't equal what? Negative 1 or 0. You know that there are therefore vertical what at those things? What are they? X equals 0 and x equals? You just figured that out. That's great. Now what do you want to try to figure out? So we did domain. What should I do next? Nope, I'm going to do symmetry next. And if you look at it, can you tell me what the symmetry is? There's none. There is none on this. If you plug in negative x, the negative x is still there, but it doesn't flip everything. There is no symmetry. What else do we find before we do our derivative? Intercepts. When x is 0, what's y? Oh, wait, it's undefined. So there's no intercept there, right? So then can you make this equal 0? Is it possible for this to equal 0 is the question. What do you think? So what, negative 1 this is equal to? So negative x has to equal x plus 1. So negative 2x is equal to 1. So what does x equal? Negative 1 over 2. So when it's negative a half, what does y equal? 0. Can you test that? Sure. What's y of negative a half? 1 over negative a half plus 1 over, what's negative a half plus 1? Right? So what do you end up with? Negative 2 plus 2 is? So did that check out? It did. So we do have an intercept at negative a half 0. Is that helpful? Yeah. Find some things out before you immediately go to the derivative. Are you definitely going to have to do the derivative at some point? Yeah, but find some stuff out before then. What should we do before we find the derivative? How should I rewrite that? To the negative 1 plus. It's definitely easier to take the derivative of that because you don't have to use, now we don't have to use what? We don't have to use the quotient. Do we like avoiding the quotient rule? Yeah. I like avoiding the quotient rule. So what does y prime become? Someone, negative x to the negative 2 minus. Yeah. Exactly. So we're using this to find out where the function is increasing and decreasing. So we're really interested in just finding out where this is equal to what? Where it's equal to what? 0. Exactly. So you have negative x over x, sorry, not negative x. So you end up with negative 1 over what? Minus 1 over plus 1 squared. So you have negative 1 over x squared is equal to 1 over x plus 1 squared. So what do you end up with? Negative x plus 1 squared is equal to? So you get negative x squared plus 2x plus 1 equals negative x squared. So negative x squared minus 2x minus 1 is equal to negative x squared. What cancels on both sides? So you end up with what? Negative 2x is equal to 1. So what does x equal? Negative a half. So what do you do after you find out where the derivative is equal to 0? What do you do after you do that? Yeah, you find the, well, not the y value, you want, yeah, eventually, but this is the x value. What do you want up here? The derivative value. What's the derivative when x equals negative a half? 0. It's in there. What's to the right of negative a half? 1. Plug in 1 into this. What do you get? Negative and minus. You get negative 1 minus what? Hold on. Why? I don't know. Good call on the mistake there. Yeah, so this is interesting. Why did I put a negative right there? I don't know. So let's get rid of there should be no net. Maybe because I was multiplying by negative on the left. I don't know. So is this completely different? Yeah. This is completely different now. So now what does it become? We have negative x squared minus 2x minus 1 equals x squared. Is that totally different now? Yeah, so you end up with 0 is equal to 2x squared plus 2x plus 1. Is that different? Yes, yes it is. Now, is that nicely factorable is the question. What do you think? Is that nicely factorable? How do you check this? What's the easiest way to check to see if it's nicely factorable? You check the, what is that called? Yeah, the b squared minus 4ac. What's that called? You call it the delta. It's the discriminant. So it's going to be b squared minus 4 times 2 times 1. What does that become? 4 minus 8 is? If the discriminant is negative, what does that mean? It never touches. It never touches. So what does that mean? So this means that f prime of x is always, or it's always one sign. It never equals 0. Do we know which one it is yet? Well, we will in a second. How do we figure out which one is it always going to be? Plug in any number into the derivative, right? Plug in any number you want into the derivative. So what was our derivative right here? What happens when you plug in 1 into this? If you plug in 1 into this right here, you get negative 1 minus a half. So f prime of x is always going to be what?
Could be negative 1. Because
I'm plugging in 1.
Oh, I see.
No, plugging in 1. If I plug in 1 into this, you get negative 1 minus what? 1/4. So negative 1 minus 1/4, is that positive or negative? Negative. So if it's negative there and it can never cross the x-axis, the derivative is always going to be what? Does that make sense? Is that true? Can it cross the x-axis? Oh, wait. There's an asymptote, isn't there? Right? Oh, how many asymptotes are there? There's 2 asymptotes, aren't there? So what do you actually have to test? When you're testing this, you have to test negative 1. These are, what happens at each of these right here? These are what? Vertical what? They're vertical asymptotes, right? So can the function jump from positive to negative on either side? The function can, but what do we know about the derivative? Can the derivative ever change sign? We have to be really careful. So what was our derivative? It was negative 1 over x squared minus, what was it? 1 over plus 1 squared. So we plugged in 1. What did we get when we plugged in 1? It was negative, right? Let's plug in negative a trillion. If you plug in negative a trillion to this, this will be negative and this will be positive. So negative minus a positive is always what? Negative. But what do we have to be careful of? What do we have to plug in between? This is f prime of x. We need to plug in something in between. What do you want to plug in? Negative a half. So not f, yeah. So f prime of negative a half, what's that going to equal? Negative 1 over 1/4 minus what? 1 over squared, right? Is that correct?
Yes.
So what's that going to equal? Negative 4, right? Minus what? Minus 4 is going to be what? So we think the derivative stays negative the entire time. We just tested it. Do we kind of think, is that possible? It is possible. It can stay possible. Okay, so let's keep moving on this. So we think this thing is always falling, but are there vertical asymptotes?
Yeah.
Yes. Can it always be, is that possible? It is possible. It is possible. I'm relatively confident we're doing okay here. So we found out, where is it decreasing? It's decreasing from negative infinity all the way to negative 1. Where else? Negative 1 to 0, and where else? 0 to infinity. Why can't we just say negative? Why can't we just say decreasing everywhere? Because it's not defined on those two values, right? It's not defined on the vertical asymptotes. Okay. So we've done where it's increasing and decreasing. What's the next thing we have to figure out? Concavity. Concavity. Nice. So we have y prime was equal to, what was it? Negative x to the what power? Negative x to the negative 2 minus x plus 1 to the negative 2. I think that's what it was, right? So what does y double prime equal? 2x to the plus 2x plus 1 to the negative 3. So y double prime is equal to 2 over plus 2 over x plus 1 cubed. So can that ever equal 0? Well, we have to figure out if it can equal 0, can't we? Is that a slightly challenging thing to do? What do you think? Let's pause. What should I do to go to the next line? Mathematically speaking, what should I do? Cross multiply. Negative x cubed is equal to x plus 1 cubed. So unfortunately, what do you have to... actually, you can do this at this point. What could you do at this point? Could you do the cube root of this?
Yes.
What's the cube root of... Well, let's try this. I'm going to put a big star here. What's the cube root of negative x cubed? Negative x. And what's the cube root of x plus 1? Sorry, the cube root of x plus 1 cubed is... So we think it's going to be negative 2x is equal to... x is equal to... negative a half. What happened before when we tried to do this over here? Do you remember which we tried to do this algebra? Do you remember this right here? We did the same thing, but what happened here? We ended up with... What happened? What's the problem here, kids? The discriminant was negative, which means that it never crosses the x-axis, right? So we came up with a problem before. So over here, can you just take the square root of both sides on that? Why not? You're taking an even root of a... Why can't you take the square root of this side? Yeah, you really should avoid taking the square root of a negative number, because what happens? It adds an... What was our original function? It's all the way back up here. Right there. As x goes to infinity, what does that go to? As x goes to infinity, what does that go to? Yeah, what's 1 over a billion? Very small. What's 1 over a billion plus 1? Very small. So what's very small plus very small? Still very small. What about negative infinity? What does it go to? Very negative, but from the other side. So what does it do over here? We know that the graph is going to look like this. But then on the other side, what's it going to do? It has to keep going down, so it's going to look like this. So we've done everything we possibly can, except for, based on this graph, if this graph was correct, what can you say about concavity? If this graph is correct, what do you think the concavity is? That's concave what? Down. What's this right here? And then what's this? And concave up. So theoretically, if that's the case, it's going to go down, up, down, up. Theoretically, it goes concave down, concave up, concave down, concave up. And remember, what's this? So this is the x value. You want the second derivative value. What was the second derivative? 2 over x cubed, right? What was the second derivative? Plus 2 over x plus 1 cubed, like that. If you plug in negative a billion into this, this will definitely be negative. So does that match right there? If you plug in positive a billion, what are you going to get? Positive or negative? Positive, because when you cube something, does it change the sign? No. This is where it gets a little bit more fun right here. I'll tell you it is correct, though. So you end up with this graph right here. What I find interesting, what do you think I think the most interesting thing about that graph is? I know that's a weird question. What do you record here? So Erica asked, it changes, you're right, it changes concavity right there, right? But here's the thing. Inflection point has what word in it? Point. It has point in it, right? So it changes concavity, but it doesn't change concavity over a point. So for me, I consider it like an asymptote of inflection. It's not a point of inflection, it's an asymptote of inflection. It changes concavity over a line. I think some books call it a point of inflection, but the problem is this. If you say you found a point of inflection, I might ask you, where is that point? And what would you say? It's not a point. I would say vertical line of inflection. It's not something you're going to get asked on any sort of test, but it's important to realize. What's the domain?
All real numbers.
No, it's all real numbers. Yeah. Is there anything you can't plug in? You can plug in anything you want. Oh, what about symmetry?
None.
There is none. What about intercepts? Did you figure this out? When x is 0, what's y?
1.
Yeah, 1. Are there any others? None, that's it. So now what do you take? The derivative. What's it going to be equal to? Well, e to the 2x minus x squared times what? 2 minus 2x, which you can rewrite as 2 times e to the 2x minus x squared times 1 minus x, like that. Correct? And you're interested in when that's equal to? This right here is what you're interested in. So what's the only way to make that equal to 0 when x is equal to 1? That's the only way to make that equal to 0. So you take this out, you plug 1 in there, so that's the x value, and this is your y prime value. What's the derivative when x equals 1? 0. So plug in, what's an easy value over to the left to plug into the derivative? 0. If you plug in 0 into this right here, what do you get? Positive or negative? Positive, and then it turns into? So where is it increasing? Negative infinity to 1. Where is it decreasing? 1 to infinity. So we have the x value here. What else should we find? Y value. So what's y evaluated at 1? It's going to be e to the 2 minus 1, which is e. So we know there, what type of point? So we know it's 1 comma e is what? Is a what? It's going up and then down. So what is it? It's actually an absolute max because it's going up to it and then it's going down. Can it ever go above it? No. Let's talk about asymptotes first. First of all, are there any vertical asymptotes? No. What about horizontal? What's the limit as x goes to infinity of f of x? 0. And what's the limit as x goes to negative infinity of f of x? It's also 0. So there's going to be a horizontal asymptote where? Y equals 0. Yeah. Great. So we have increasing and decreasing. What's the last thing we need to find? Points of inflection or concavity. Correct. This is where it gets a little bit more fun. So we have y prime is equal to 2 minus 2x times e to the what? 2x minus x squared. Let's do the derivative, but let's use the product rule. Here's the first function, and here's the?
Oh, the value for the absolute maximum is 1 e to the 3rd power.
1 e to the 3rd power?
Yeah, because it's
2 minus 1. You plug in 1 into this. What is it? It's 1.
Oh, no.
2 minus 1. Yep, it's okay. So let's take the derivative right here. You ready, kids? Use the product rule. So y double prime, what's the derivative of the first? Just negative 2, right? Negative 2 times e to the 2x minus x squared. Oh, not 2x squared. X squared. Plus what? 2 minus 2x times e to the 2x minus x squared times 2 minus 2x. But what can we do? Just square it, right? We're now interested. What's the domain of this second derivative function? Is there anything we can't plug in? No? Don't move. So we set this equal to 0. Are there inflection points? solve. Okay.